square minus 3d plus 2 into y equal to x into e power 3x plus sine 2x. Now this is the differential equation with the constant coefficient, but in the right hand side there are two terms, so we have to apply particular integral 1 and particular integral 2. So first I am going to find out the complementary function. To find the complementary function, we have to write the auxiliary equation. So auxiliary equation is replacing d by m, so that m square minus 3m plus 2 equal to 0. This 2 can be written as minus 1 into minus 2, which is equal to minus 3, so that m minus 1 into m minus 2 equal to 0. So m equal to 1 and m equal to minus 2. So therefore there are two values for m, both are different, unequal. Therefore the complementary function is a in t power m1x plus b in t power m2x. You can treat anyone as m1 and m2, so I am going to take this as m1 and this is m2. So the complementary function is a in t power 1 into x plus b in t power 2x. So this is the complementary function. So after obtaining the complementary function, next I am going to find out the particular integral, but there are two parts in the right hand side. So first I am going to find particular integral 1, next I am going to find particular integral 2. Okay, now first particular integral 1. Therefore here 1 by d square minus 3d plus 2 into x into e power 3x. So this is the particular integral 1. You see, this is the type 5, because e power ax into v is x. So in this fifth type, replacing d by d plus 3, because coefficient of x is 3. So in this type, replacing d by d plus the coefficient of x 3. So that after replacing d by this, keep e power term here. So e power 3x here, 1 by d plus 3 the whole square minus 3 into d plus 3 plus 2 remaining x term. So now next I am going to apply a plus b the whole square here. A plus b the whole square, a square plus b square plus 2ab, 2 into 3 6d, multiply minus 3d inside, minus 3d minus 9 plus 2 into x. Okay, now further e power 3x into 1 by d square, 6d minus 3d, so this is 3d, plus 9 minus 9 cancel, plus 2 into x. Okay, now next I want to simplify this, but this is the type 4 algebraic model. So we have to apply binomial formula by taking the constant outside. So here I am going to take constant 2 outside. So here e power 3x, 1 by, take 2 outside. So when you take 2 outside, this become 1. So for the entire these two terms, we can write d square plus 3d by 2 into x. After this I am going to take in the numerator, then I am going to apply binomial formula, we can find the solution. Okay, now you see here I am going to take this term in the numerator, so this power minus 1. So e power 3x by 2 taking the numerator. So e power 3x by 2 and taking the numerator power minus 1. Okay, now here I am going to apply the formula 1 plus x the whole power minus 1, binomial formula. So this is the binomial formula, 1 plus x the whole power minus 1, 1 minus x plus x square minus x cube plus etc. So here x is, this entire term is x. So expand this binomial formula up to the power 1. It is enough because this is the x power is 1. So we don't want to expand more value, simply up to power 1. So now e power of 3x by 2, applying the binomial formula 1 plus x the whole power minus 1, 1 minus x, so this is x, plus x square d square plus 3d by 2 the whole square minus etc. into x. After applying this formula, I am going to neglect the higher order. But you see x power is 1. so that I am going to collect only up to the power 1. Remaining I am going to neglect. Okay, so because higher power will be 0, e power 3x by 2 into 1 minus multiply means d square by 2 minus 3d by 2. Then here this can be eliminated, higher power all we can eliminate into x. And here this is also we can eliminate because d square into x is 0, because 2 time differential with respect to x is 0. So this is also we can eliminate, or we can keep inside. For example, e power 3x by 2 into multiply x inside 1 into xx minus d square by 2 into x minus 3d by 2 into x. Okay, now e power 3x by 2 into x minus x differential with respect to x 2 times, it is 0, minus x differential is 1 with respect to x is 1, so only 3 by 2. So this is x minus 3 by 2. Further I am going to simplify. E power 3x by 2 into cross multiply 2x minus 3 by 2. So finally the particular integral 1 is equal to e power 3x by 4 into 2x minus 3. So this is the particular integral 1. So next I am going to find out particular integral 2. So next I am going to find out the particular integral 2. So pi 2, particular integral 2 is equal to 1 by d square minus 3d plus 2 into sine 2x. So this is type 3. In this type 3 we have to replace only for d square, not for d. So here the coefficient of x is 2, so a is 2, so d square is replaced by minus a square, so minus 2 square is 4. So only replacing this d square, not for d. So that 1 by minus 4 minus 3d plus 2 into sine 2x. Okay, now simplification is minus 3d minus 2 into sine 2x. So, and then take minus in the numerator, so minus 1 by 3d plus 2 into sine 2x. But I want the denominator d square, then only I can replace d square value, because sine the third type you have to replace only for d square, not for d. So that I want to convert this to d square by taking the conjugate. So now minus 1 by 3d plus 2 into 3d minus 2 divided by 3d minus 2 into sine 2x. So after taking the conjugate, so this into this minus 3d minus 2 divided by a plus b into a minus b, a square minus b square into sine 2x. Again we have denominator in d square, so d square is replaced by minus a square, so it is minus 4. So replacing here, so minus 3d minus 2 into sine 2x divided by, replacing d square by minus 4, so 9 into minus 4 minus 4. So what is the value? Minus 1 by 9 4s are 36. 36 minus 4, so minus 40 into multiply sine 2x inside 3d sine 2x minus 2 sine 2x. So and then next to minus cancel, so 1 by 40 into differential of sine 2x is 3 into cos 2x into 2 minus 2 into, here there is no d, so we don't want to differentiate, only sine 2x. So now we can take 2 outside, cancel this. So finally particular integral 2 is equal to, when you take 2 outside, cancel this, 1 by 20 into 3 cos 2x minus sine 2x. So this is the particular integral 2. So next the solution is y is equal to CF plus pi1 plus pi2. So we found all the values. So CF is a in t power of x plus b in t power 2x, and the particular interval 1 is e power 3x by 4 into 2x minus 3, and the particular interval 2 is 1 by 20 into 3 cos 2x minus sin 2x. So this is the solution of the given differential equation.